Are you able to see my screen? I hope you are able to see my screen. So, good evening, everyone. I am Keshav. I am currently research scholar at IIT Kanpur. So, I am taking this problem solving session for week 4 of NPTEL course ME111, which is applied numerical methods. Okay. Are you able to see my screen now? Hello. Okay, fine. So this is week 6 problem solving session for applied numerical method course NPTEL ME111. Okay. So in this week, what has been discussed? Numerical integration has been discussed in week 6. Okay. So when we do analytical integration, this analytical integration is applied over a function. Okay. This function is generally continuous. This function is continuous or piecewise continuous. Okay. This is either continuous or piecewise continuous. So what will happen if I do not have a function? Suppose we have a function whose analytical integration is not possible. Okay. Suppose we have a function that's analytical integration is not possible. In that case, we can go for numerical integration. Okay. Or in some cases, we do not have function value at every point in the domain, rather than we have the value of the function at some discrete point. In that case, also going for numerical integration is beneficial, and we have there is only one possibility to go for numerical integration to find the values. Okay. So first thing is that numerical integration is conducted over discrete points. Means there are some points where xi and yi are known. Okay. It is not known at every point in the domain. So what we do in numerical integration, First, using these discrete point, we find a interpolating polynomial. Okay. How to find the interpolating polynomial, that has been discussed in the week 5. We have seen Lagrange polynomial and other polynomial also. Here we will use mostly Lagrange polynomial. So we can find the polynomial over a discrete point. Once we have found out the polynomial, then we can integrate that polynomial to find the numerical integration. Okay. Since, as we have already discussed, that numerical methods always gives us some number. It will not give us the expressions. Okay. This means what? The numerical integration can be applied only to solve definite integral problems. Okay. So where it can be applied, or where it is preferred to be applied, when analytical solution is not possible, analytical integration is not possible, or we have only a discrete point that is known. Okay. Fine. Now we will discuss the first type of numerical integration, that is numerical integration using trapezoidal rule. Okay. So just respond whether I'm audible correctly and you are able to see my screen. Okay, thank you. So first method is trapezoidal method. So here we have seen that there are two steps involved in numerical integration. First step is finding the interpolating polynomial. Okay. So the simplest process can be, the simplest form of polynomial can be, the simplest form can be linear. Okay. So in trapezoidal rule, we assume a linear polynomial, linear interpolating polynomial. So if I write in journal y as Lagrange interpolating polynomial, that will be equal to I equal to from 0 to n, means we have point starting from 0 to n, means n plus 1 point, that can be represented as Li function of at xi point. Okay. Which means for the linear case, we can write as y will be equal to L0 f at x0 plus L1 f at x1. Okay. Now how can we write this Lagrange polynomial function? This Li, sorry, yeah, we can write as j goes from 0 to n, j not equal to, here there is mistake, j not equal to I, x minus xj divided by xi minus xj. Okay, this is the function. So by using this function, I can write L0. Here we have 2 point only, x0 and x1. So L0 will, j will go from 0 to 1. Okay. So for 0 case, j will not be equal to 0. So it will be equal to x minus x1 divided by x0 minus x1. Similarly, I can write L1, that will be equal to x minus x0 divided by x1 minus x0. Okay. So we have found L0 and L1. Now we wish to find this integration, which is y dx, x goes from x0 to x1. Okay. That will be equal to, since this f of x0 is constant, that will come outside of the integration. So we need to find L0 dx, where limit goes from x0 to x1. And similarly, we need to find this to evaluate this integration. L1 dx limit goes from x0 to x1. Okay. Now you put this L0 value and L1 value here and integrate it. So x minus, this is some constant x1 and x0. These are constants. So their integration will be x minus x1 whole square divided by 2, and this is constant, it will remain as same. Similarly here L1 integration will be what? X minus x1, x minus x0 whole square divided by 2, and this will remain as same. Now you put the limit. If you put limit here x1, what will be? This will become 0. When I will put x0, so x0 minus x1, x0 minus x1 divided by x0 minus x1, here it is whole square, so 1 will be cancelled. So it will come f at x0 same. There will be minus sign, since when we put x1, that becomes 0. So minus x0 minus x1 divided by 2 plus f at x1, x1 minus x0 divided by 2. So similar x1 minus x0 we can take outside, and this 2 is also common, so we can take outside. So this will become integration y dx, limit goes from x0 to x1, that will be equal to x1 minus x0 divided by 2 multiplied by f at x0 and f at x1. So this is what, if I write simply this in short form, y at 0, and this in the short form y at 1. So this will become y of dx, that will be equal to x1 minus x0 divided by 2 y naught plus y0 plus y1. Okay. So what we are doing basically, so suppose we have some function like that. This is y equal to fx. Okay. We have only 2 point a and b that are known, x0 and y0, and we do not know this function. So what we are trying to do, we are trying to make a linear interpolation between these point A and B. Then we are trying to find out the area of this trapezoidal. So this is nothing but the area of the trapezoidal, means what? Summation of parallel parallel dimension divided by the distance between that. So y0 and y1 are parallel, so that summation of that, and its difference between that will be what? X1 minus x0 divided by 2. So this is nothing but the area of trapezoidal ABCD. That's why it is called trapezoidal method. Okay. So this is the important formula. If I assume x1 minus x0, this is equal to h. H is what? Step size, or it is also called as grid size. If I assume this as h, so I can write integration x1 to x2 y dx, that will be equal to h by 2 y0 plus y1. Okay, this is the formula we will get. Now we will see how to find out the error that is involved in the numerical integration. Okay, so first we will start with, since we have discussed just now trapezoidal rule to find out the numerical integration. Now we will discuss what is the inner error associated with it. So if you recall, in last week we have discussed that the error involved in Lagrange interpolation, if my function is fx and this is my interpolating polynomial p of x, so this difference f of x minus p of x, that will be equal to n plus 1th time derivative of this function at some point xi is between the interval, divided by n plus 1 factorial multiplied by this term, which is I goes from 0 to n multiplication of x minus xi. Okay. So here for this case, if I write, so this y dx means this function, this is nothing my y, this is nothing but my y. So if I want to find out y dx, so I will integrate on both sides. Okay, I will integrate on both sides. Okay, from whatever x0 to x1, suppose I want to find x0 to x1, x0 to x1. Now I take this minus p of x dx to other side, right hand side. So this p of x dx plus this either whatever we have found from limit goes from x0 to x1. Here, how many points we have? 2 points we have. Okay, 2 points we have 0, x0 and x1. 2 points we have. So what will the order of this polynomial? This is linear, so order will be 1. So n is equal to what? N is equal to 1. So n plus 1 will be 2. So that's why here it has been written f double prime of xi. And this, if you replace n with 1, you will find 2 factorial, that will be equal to 2. Now here I goes from 0 to 1. Okay, so x minus x0, x minus x1 multiplied by dx. Now you simply, this is some kind of constant, it will come outside of the integration. So this is what the numerical integration that we are finding. So this I plus 1 by 2 f double prime at some point xi, okay, and this integral. So if you integrate it, and put x1 minus x0 equal to h, if you integrate it and put this value, you will find this expression. Okay, so this I will be equal to what? This I will come from trapezoidal rule h by 2 y naught plus y1, and this integration, this will give me x1 minus x0 whole cube divided by 6. So if I multiply 1 by 2, so that will be equal to, this will be equal to h cube divided by 12 f double prime of xi, which means what? This is some order of h cube. Okay, which means what? If I do the numerical integration of some function, I will get third order accurate solution. Okay, this doesn't mean that our accuracy will be order of, if h is h, it will be order of h cube. It means that if I decrease the step size, then my accuracy will increase, or my error will decrease with proportional to h cube. Okay, this doesn't mean that my error is order of h cube. It means that if I decrease the step size h, so my error will decrease with h cube. Okay, clear? Now, since what we have done, since we have assumed the polynomial as linear, if my function itself that we wish to find the numerical integration is linear, then this technique will give me exact solution. Okay, suppose we have a known function which is linear. Okay, so if I solve this function using numerical integration using this trapezoidal rule, then what will we find? The value that will find using this trapezoidal rule, that will be the exact value of analytical integration. Okay, so now we will see composite trapezoidal rule. So earlier what we have taken? We have taken only 2 points. Okay, here some point A, some point B, between that we have found out the integration. Suppose now we have n plus 1 points. Okay, x0 to xn, we have n plus 1 discrete point. Okay, and we are assuming uniform step size. Okay, which means what? For every I goes from 0 to n, I plus 1 minus xi, that is equal to h, which is step size, and it is uniform. Okay, that we are assuming. So suppose we want to find out the integration. So this integration will be what? This integration will be summation of this integration, summation of this integration, summation of this integration, summation of this. So if I want to find y dx, limit x goes from x0 to xn, I can break it into y dx, limit of x goes from x0 to x1, x1 to x2, Similarly, x2 to x3 dot 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 xn minus 1 to xn. Okay. So using the trapezoidal roof, if I want to find for any y dx, limit x goes from xi to xi plus 1, that will give me h by 2 yi plus yi plus 1 plus some order of h cube. Okay. So similarly, I put the values here. This is the first value. This is the second integral value dot dot. This is the nth integral value. Plus we will get this order of h cube, that will be n times, since we have performed this integral n times. So this will be added. So it will come as n. Okay. Now this n can be represented as number of interval that will be equal to total difference divided by the step size. Okay. So this I have put here. So now h came in the denominator, that will cancel one of the h, and we will get y dx limit x goes from x0 to x1 x0 to xn, that will be equal to h0 will be common from outside. First y0 plus yn, and other will be 2 times multiple, 2 times y1 plus 2 times y2 dot dot 2 times yn minus 1, and its order will be h square. So this is composite trapezoidal. It is what? It is second order accurate. Okay. Now we have seen that the trapezoidal rule locally is what? It is locally third order accurate, while globally it is second order accurate. Okay. So now we wish to improve the accuracy of this numerical integration. Okay. So what we are doing here in numerical integration, first we are fitting a interpolating polynomial, then we are integrating that polynomial that we have got after the fitting. Okay. So the accuracy of trapezoidal rule can be improved, or the accuracy of the numerical integration can be improved if we fit rather than linear, if we fit quadratic. Okay. Means what? N will be equal to 2. Okay. So this method is called Simpson one-third rule. In Simpson one-third rule, why it is called Simpson one-third? We'll come into that. So here, what we are wish to show, that we are interpolating y equal to, using Lagrange interpolation, I equal to 0 to n li f at xi, and we are going for a second order polynomial. Okay. So using the same formula, if I write L0, that will be equal to x minus x1, x minus x2 divided by x0 minus x1, x0 minus x2. Similarly, L1 will be what? X minus x0, x minus x2 divided by x1 minus x0, x1 minus x2. Similarly, L2 can also be written. Now, if we wish to find y dx, limit grows from x0 to x2, that will be equal to this. These are constant, they will come outside, and integral of L0 dx, integral L1 dx, L2 dx. So what we are doing here, suppose this is this blue color is the actual function. We have only 3 points known here. Okay. These 3 points x0, y0, x1, y1, x2, y2 are known. So if we are using the trapezoidal method, so what we will do, if directly we are using, suppose these 2 points x0, y0, x2, y2. So this will be my trapezoidal area. Na? So this is the yellow color, sorry, the green color that we have found. This is the interpolating polynomial. Okay. But if I use this second order polynomial, so I will find this pink color. So area under this curve will be given by Simpson one-third rule. Okay. So now if you do that, if you put the L0 from the formula that we have represented here, you put here and go do the integration. Then, and assuming that H is uniform and it is the step size or grid size, we'll find out the formula. We'll find the formula y of dx limit x goes from x0 to x2. That will be equal to step size, which is x, divided by 3, f at x0 plus 4 multiplied by f at x1 plus f at x2. That can be represented as h by 3. This 3 is coming here. That's why it is called 1/3 rule. Okay, so h by 3, y0 plus 4 y1 plus y2. Okay, now if I want to write it in composite form, so this term, if I make here like that, suppose this is the our function, this is my 0, this is my 1, this is my 2, this is my 3, this is my 4th, this is my 5th, this is my 6th point, this is my 7th point, suppose. Okay, so these 3 points will be used in the first integration, these 3 points. In the second, these 3 points will be used. So this point comes 2 times. Okay, similarly this point will come 2 times. No, so that's why y2 will be come 2 times, y4 will come 2 times. So every even term will come 2 times and odd terms will come as multiple or 4, and first and last point will come like that. So this is the formula for Simpson 1/3 rule. Okay, so Simpson 1/3 rule is locally fifth order accurate. You can find out the accuracy as well, like we have found in the trapezoidal method. So it will come as fifth order accurate. And if we go for globally, it will be fourth order accurate. Okay. So this is Simpson 1/3 rule. So if I write both combinedly, trapezoidal rule will give y dx, that will be equal to the interval of that, or the step size of trapezoidal method, ht by 2, y0 plus middle term will come as multiple of 2 plus last. Okay, this is the formula and it will be second order accurate. And if I write the formula using the Simpson 1/3 rule, that will come the step size in Simpson hs by 3, y0 plus last term ym plus odd term as multiple of 4 and even term as multiple of 2. Okay, and it will be fourth order accurate. Okay, so in general we can write any numerical integration y dx limit x goes from x0 to xn, that will be equal to I goes from 0 to n, some weight wi f of xi, and this general notation is known as Newton-Cotes formula. Okay, now if you see in Simpson 1/3 rule, the number of intervals should be multiple of 2. How? If you see here, how many intervals we have? This point, 2 points. So this is one interval. This is the second interval. Okay. So this required 2 interval for computing locally this Simpson 1/3 rule. And composite will be what? Composite will be combination of this local Simpson 1/3. So from here it will come 2, from here it will come 2, from here it will come 2, which means what? The intervals will be always should be multiple of 2 to apply the Simpson 1/3 rule. But there is no such restriction in the trapezoidal method. But what is the problem with trapezoidal method is that this is less accurate. Okay, so that's why Simpson 1/3 gives us some accuracy, but there is one issue here, that it is requires even number of intervals. Okay, so what will happen if we have odd number of intervals? Then we need to go for a trapezoidal rule. That will lead to less accurate solution. So that's why a new method has been introduced, that is known as Simpson 3-8 rule. Okay, this method is as accurate as Simpson 1/3 rule, and it requires the interval in multiple of 3. Okay, so what we do here, here we fit third order polynomial. Okay, here we fit third order polynomial, which means what? 4 points, first point, second point, first point, second point, third point, 4 point. How many intervals we have? This is the first interval, this is the second interval, this is the third interval. Mean locally Simpson 3/8 rule will have 3 intervals, and if we are finding composite of it, this 3 3 3 3 will be added, which means what? The n should be multiple of 3. So this y I can write using Lagrange interpolation function for third order polynomial as L0 y0, L1 y1, L2 y2, L3 y3. Okay. What will be the formula of L0? X minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3. Similarly, L1 if I write from here in nominator, x1 term will not be there, and denominator every term will have x1 as a first term. So x minus x0 multiplied by x minus x2, x minus x3. Similarly, in denominator x1 minus x0, x1 minus x2, x1 minus x3. Similarly, L2 and L3 you can write. Here we are assuming suppose uniform grid. Okay. So this integration Li dx limit goes from x0 to x3. We can write as pi h cube integration x0 to x3. This is the formula of nominator. This is the formula of nominator of Lagrange polynomial function. Okay. So if I write L0 dx, so this will be b0 h cube. Here if you find the b0 values, suppose if I write here, this is what? X0 minus x1. This is h minus h. This is what? Minus 2h. This will be what? Minus 3h. If you multiply that, that will come minus 6h cube. So h cube we have already written here. H cube we have already written here. So b0 will be what? Minus 6. Similarly, b1 will come 2, b2 will come minus 2, and b3 will come 6. Okay. But now I wish to find this L0 dx limit goes from x0 to x3. Okay. So this will come as constant outside. Now we want to find out integral of this. So you can assume this as second function and this as first function and do the integration by parts. Then if you do that, you'll find this is the value that we will get. Okay, minus 9h divided by 4b naught. And if I write this in general form, Li dx limit x goes from x0 to x3, that will be equal to minus 1 to the power I plus 1 9h divided by 4bi. Okay. So similarly, you put these values here. So 9h by 4 will become outside, minus y0 by b naught plus y1 by b1 minus y2 by b2, y3 by b3. Okay. You put these values b0 as minus 6, b1 2, b2 minus 2, b3 6 in the formula here. Then you will get y dx that will be equal to 3h by 8 y0 plus 3y1 plus 3y2 plus y3. Okay, this is the formula we will get. Now if I want to write in composite fashion, so this y0 and yn will come. Similarly, these terms and these term will be remain same, multiple of 3, and the multiple of the term that is multiple of 3, that will be that will have coefficient as a 2. Okay, this will come the y1 y2 y0 y1 y2 y3 1 2 sorry 0 1 2 3. Okay, similarly here 4 5 6. Okay, so these 4 points will combinedly find locally 3 3 8. Then these 4 points will locally find 3 8. So this point has come 2 times. That's why this will be multiplied by 2. Okay. It has the same accuracy as Simpson 1/3 rule. Okay. So what we have found here, that if we have the interval multiple of 2, we can go for Simpson 1/3 rule. And if we have interval as multiple of 3, we can go for Simpson 3/8 rule. Okay. Then combination of these two, 3/8 and Simpson 1/3 math rule can be used. Their combination can be used when our interval number of interval n is neither multiple of 3 nor multiple of 2. Suppose we have 7 here. Okay. 7, we have 7 intervals, means 8 point. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 1, 2, 3, 4, 5, 6, 7. Huh? So this is what we have, suppose. Then for these 3, we can apply 3/8 rule. And for this 4, we can apply 1/3 rule. Okay. Fine. So now we have seen 3 methods to evaluate the numerical integration. First method is trapezoidal rule, trapezoidal method or trapezoidal rule to find out the numerical integration. Second was Simpson 1/3 rule to find numerical integration. Third one was Simpson 3/8 rule to find out the numerical integration. Okay. Now we'll see the Gauss quadrature method. This Gauss quadrature method is quite accurate. That's why if you do any commercial software you are using, which is doing this numerical integration as an inbuilt function, that will use this new Gauss quadrature method, since it is very accurate method. Okay. So what is the main motive to use this Gauss quadrature method? Suppose we want to use the linear function. Okay. If we have a linear function, this y equal to fx, this fx is linear, suppose. So what will happen? Linear. What will happen if I use trapezoidal method, that will give me the exact solution. Okay. Similarly, if I have second order polynomial, then if I go for Simpson 1/3 rule, that will give me a exact solution. Okay. Similarly, if I go for, if my function is y equal to fx, which is third order polynomial, and if I go for Simpson 3/8 rule, that will give me the exact solution, means what exact integration that I will get, integral value that I will get using the analytical, if its analytical solution is possible. Okay. So suppose we have 2 points here. Okay. This a point, this and this b point, and we have some function, this function y equal to fx. Okay. Now what we are going to do, we wish to find AB. It need not to be the end point of the interval. We wish to find this AB such that by using the trapezoidal method, we can find the exact solution of this function, which is not a linear function. This y here is not a linear function, but we want to find exact solution using the trapezoidal method. In that fashion, that we will choose this A and B such that the integration using the trapezoidal method will give the value as a exact integration. Okay. So suppose this is my -1 to 1. So I want to find -1 to 1 y dx using trapezoidal method means some c0 f at x0, c1 f at x1. This x1 and x0 is unknown. Similarly, c coefficient c0 and c1 is unknown. So we have 4 unknowns. Okay. So we can assume y as a same function to find out the exact solution. Means if y is 1 or y is x or y is x square or y is x cube, or their any linear combination, then it will give me this function will give me exact integral. Okay. So suppose y equal to 1, then x square, then x cube, then its integration minus 1 to 1 will what? It will be 2, it will be 0, it will be 2 by 3, and it will be 0. Similarly, minus 1 to 1, if y is a odd function, it will be 0. If y is suppose is constant, so it will come outside and it will be 2. You simply do the integration and you will find the values like that. Now, if we use this RHS of this, whatever we used to find by trapezoidal, it will what? If I put y as 1, it will become C0 plus C1. If I use as x, C0 x naught, C1 x1. If x square is used, C0 x square, C1 x1 square. Okay. So this is the 4 equation that we have found, and we have 4 unknowns. So if I write the equation C0 x0 plus C1 x1, that will be equal to 0. Similarly here, C0 x0 cube plus C1 x1 cube, that will be equal to 0. And C0 C1, C0 plus C1 2, C0 x0 square, C1 x1 square, that will be equal to 2 by 3. Now from here, if you see, from here we can find out that x0 will be equal to minus x1, and C0 will be equal to, from these two equations, C0 will equal to C1. And by using this equation, we can find C0 and C1 will equal to 1. And by using this equation, we can find this. Okay. So we have found out the values. So therefore, if my y is function f of x, I can assume a0 plus a1x plus a2x square plus a3x cube. Then if I use f at minus 1 upon root 3 plus f at 1 upon root 3, that will give me the exact integration. Okay. So this is what Gauss quadrature method. So if I go for, rather than 3 point, if I go rather than 2 points, if I go for 3 points, so this can be found using the same method. Okay. Using the same procedure, we can find Gauss quadrature method using 2 point, Gauss quadrature method using 3 point. Then this weights we can find. Here we have found 1 1 and minus 1 upon root 2, minus 1 1 upon root 3 and 1 upon root 3. Similarly, 3 points also you can found. These all tables for Gauss quadrature method is given in the textbook. So this will be given to you if they are wished to you to find out the solution of integration using the Gauss quadrature method, then this table will be given to you. Maybe if 2 point Gauss quadrature method, the problem came, then they may not give you the table. But otherwise, if they are using higher number of points to find out the Gauss quadrature integral, then they will give this table. Okay. So now whatever we have did here, we have found the integral minus 1 to 1 y dx. So what will happen if we go for arbitrary interval? So this arbitrary interval f of x dx a to b limit can be changed to minus 1 to 1 gt dt. Okay. Multiplied by b minus a by 2. Okay. Where this t will be equal to 2x minus a minus b divided by b minus a. Okay. By using this replacement, we can convert a to b to minus 1 to 1 type of integral. Okay. By using these two substitution, we can convert any arbitrary interval to minus 1 to 1. Okay. Now we'll go for double integration using the numerical method. Okay. So what we do basically in double integration, we take a small area dx dy, and if we want to find out the integration area, we double integrate it dx dy. Okay. or if we found we wish to find out some t dx dy, then what we can do, first we can integrate this integration t dx, then we integrate by dy. Okay, means what, when we are doing this integration, we are assuming y as constant. Okay, y as constant means what, first we are finding out this, then we are sorry. Suppose t dx, what we are doing, this we are converting to this strip. This small segment we are converting to this strip. Now we are integrating this strip to our y domain. Okay, this is what we are doing. Means first we are integrating with respect to x, then we are integrating with respect to y. This can be done numerically as well. Suppose I am using trapezoidal method. So suppose first I have integrated with, suppose first I have integrated with y. So what I will find, for every x we will find, suppose I have integrated with only y. So I have found h by 2 y0 plus 2 y1 plus 2 y2 dot yn. And these yi's are the integral evaluated as specific x. So here what it has been done, like that is had been done. So first it has been integrated with respect to y. So I have this small domain. I have integrated with respect to y, means what, we have found out this strip. Okay, this strip. This is what, this is kind of an integration. So with respect to y, first we have did, then we have integrated this strip over this limit. Okay, so first y, then at each x we have did this. Okay. So numerical double integration can be implemented as a series of single integration. From here we have seen. Okay. Triple integration, how can we can find? Triple integration we can find as a series of double integration. Okay. This is a straightforward thing. Fine. Clear it till now, whatever we have discussed. Is it clear? Okay. So now we will solve some problem. You also try to solve these problems. Okay. I will also solve. So this is the first problem. We have a certain function y equal to fx such that y at x equal to 1 is 1, y at x equal to 2 is 4, y at x equal to 3 is 27. Okay. And we wish to find limit from 1 to 3 y dx using trapezoidal method. Okay. So you see here, first I will solve first problem, then you go. Okay. Then you solve. So what we have here, we have y at x equal to 1 equal to 1, y at x equal to 2 is equal to 4, and y at x equal to 3 is 27. And what we wish to find? We wish to find this integral using trapezoidal method. Okay. So here by using this, I can show that here h is what? 1. Then it is x is changing with one gap of 1, and x0 is 1, x2 is 2, sorry, x1 is 2, and x2 is 3. Okay. Similarly, y0 is what? 1, y1 is what? 4, and y2 is 27. Okay. Okay. Now, if by using the trapezoidal method, if I want to write this formula, this will be h by 2, first one y0 plus last one y2, because whatever term will be, that will be multiplied by 2. Okay. So this is the formula here. So simply I put the value h is what? 1, 1 by 2. Y0 is what? 1 plus 2 multiplied by y1 is what? 4 plus y2 is 27. So this is 8. So 36 divided by half, 36 half, that will be 18. So this will be my answer. Okay. Now you solve this problem using Simpson 1/3 rule. So this is the using. Now you solve this using trapezoidal method and tell me the value. So this is what we wish to find: 1, 2, 3 y dx, that will be equal to, using Simpson 1/3, h by 3, first term y0 plus last term y2, plus the odd term will be multiple of 4 and even term will be multiple of 2. But here we do not have any even term, so it will be directly y2. What will be the value? H is what? 1, 1 by 3, 1 plus 4 multiplied by 4 plus 27. So 16, 16, 17, 17, 7, 34, 34, 44. Okay, so it will come 44 by 3. 44 by 3, that will be equal to what? Tell me the value. So 1, okay, 14.667. Okay, like that. Good. Now this is the next problem. Consider we wish to find this integral I equal to the function 0.2 plus 25x minus 200x square plus 675x cube minus 900x to the power 4 plus 400x to the power 5 dx. We wish to find this from limit goes from 0 to 0.8. Okay. And we want to use the trapezoidal rule to find out the error that is involved in this numerical integration. So this error is defined as modulus of I analytical minus I numerical divided by I analytical. Okay. So this is my function. So I want to find out error for 3 step size: 0.8, 0.4 and 0.2. Okay. So first what we need to do? First we need to find out the analytical solution of this function. So what is the function here? Let me write the function. F of x is equal to 0.2 plus 25x plus 25x minus 200x cube, I think 200x cube x square plus 675 x cube minus 900 x to the power 4 plus 400 x to the power 5. Okay. This is what we have, the function. Okay. This is the function we have. Okay. So suppose I want to, I will solve for one point. Okay. Suppose I want to solve for step size as h equal to 0.2. Okay. H equal to 0.2. I will solve and you solve for other two. Okay. So step size, suppose I have assumed as 0.2. So what will be the value of x? So x0 will be what? 0. X1 will be what? 0.2. X2 will be what? 0.4. X3 will be what? 0.6. And X4 will be what? 0.8. Okay. At this point, if I find out y0, which is what? F at x equal to 0. Okay. Similarly, y1, if I want to find, this will equal to f at x equal to 0.2. Similarly, y2, that will be f at x equal to 0.4. Y3, that will be f x equal to 0.6. Y4 will be what? F at x equal to 0.8. Okay. So you put the value here. If I put the 0, that will come as 0.2. Now suppose I am doing the calculation here for in the calculator for this 0.8. Okay. So 0.2 plus 25 multiplied by 0.8 minus 200 multiplied by 0.8 multiplied by 0.8. Oh, sorry. 0.8 multiplied by 0.8 plus 675 multiplied by 0.8 multiplied by 0.8 two times, no, three times, 0.8 minus 900 multiplied by 0.8 8 to the power 4. No? So this will come as this will come as so this will be equal to 0.232. Then please tell me the value of this and this. So I have already calculated. So I will write directly the values. So 1.288. So this will be 1.288. This will be 2 point something. 2.456 and this 0.456, 2.456, 2.456 and 3.464. Okay, so this is what we have found. Okay, good. Now I want to write down the formula for trapezoidal method. So first, let me find out the analytical solution. Okay. This will be integration 0 to 0.8, 0.2 plus 25x minus 200 x square plus 675 x cube minus 900 x to the power 4 plus 400 x to the power 5 dx. Okay. So this will be what? 0.2x plus 25 by 2 x square minus 200 by 3 x cube plus 675 by 4 x to the power 4 minus 900 by 5 x to the power 5 plus 400 by 6 x to the power 6. Limit goes from 0 to 0.8. If you put 0, it will be 0. So we just need to find out this expression value at 0.8. So if you do that, what will the value? Can you tell me the value of this expression at x is equal to 0.8? Please tell me the value, whatever you have found. This will come as 1.640. Have you found the same value? Please check. I hope you have found out the same value. Okay, so now please concentrate here for a few minutes. Please concentrate here. So here how many points we have? 5 points, no? So if I write I numerical, this I numerical I have found for h equal to 0.2 step size and using trapezoidal method, okay? So this will be equal to h by 2, first 0 plus last one is what? y4. Other term will be multiplied by 2. So y1. Now these values will be put there and we will find out the value, okay? Value of I numerical. So this is 0.2 divided by 2. So y0 is 0.2 plus 2 multiplied by this is what? Y1 is 1.288, I hope. 1.288 plus 2 multiplied by y2 is what? 2.456. 456. Okay. Plus y3 is what? 3.464. 464 plus y4 is what? 0.232. So now if you do the calculation, what is the value you are getting? Let me do it for so 0.2 plus 2 multiplied by 1.288 plus 2 multiplied by 2.456 plus 2 multiplied 3.464 plus 0.232. If I divide it by 10, this is the value. Yeah, you have got the right value. 1.4848. Okay, so let me check whether I have found the same value for that case. No. Okay, so this is the value we are getting now. This is the value we are getting. So you please check whether we are getting this I am getting this value is correct or not. Okay, this you need to check these value. Okay, f at means in this expression you put x as 0.6. So if I want to find out the error, that error will be I analytical minus I numerical divided by I analytical. Okay, modulus. So I analytical 1.6405 minus I numerical whatever we get and 1.6405. Okay. Zero point 0.2 plus 25 multiplied by 6 minus 200 multiplied by 0.6 675. Yeah, it is correct now. Okay, so this formula is correct. So the formula for trapezoidal rule, is this correct? Let me check again the formula for trapezoidal method. Yeah, this is correct again. So what is the value we have found? 1.4848, right? So you put here 1.4848, 1.4848. Now if I find out the difference, 1.6405 minus 1.4848 divided by 1.6405. So 0.094. This is the error I am getting. Okay, by using this method, by using the step size as 0.2, by using the step size as 0.2 and using the Simpson 1/3 rule. Okay, sorry, no, trapezoidal rule. So now if I want to go for what? Simpson 1/3 rule. Okay, so I have one more problem similar to that. Let me show you again. So here we need to solve the same problem using Simpson 1/3 rule, is considering step size as 0.4 and 0.2. Okay, so for the 0.2 case, I will solve. So I analytical already we have found out. We have already found out it was what? 0.6405 something. Okay. Now I numerical I want to find using 1/3 rule, 1/3 Simpson. Okay. Using the step size as 0.2. I am writing in rough fashion, but you need to write it clearly, okay, in your exam. So that will be equal to what? H by 3, first one plus last one by 4. Odd one will be multiplied by 4 and even one will be multiplied by 2. So this is the formula. Now if I put the value 0.2 divided by 3, y0 is what? 0.2 plus 4 multiplied by 1.288 is what? Y1 plus y2 is what? 2 multiplied by 2.456, I guess, plus 4 multiplied by 3 point. What was the value of this? 456 and 464. 456 and 464 plus last one y4 is what? 0.232. 0.232. If I find out this value, what it will come? 0.2 plus 4 multiplied 1.288 plus 2 multiplied by 2.456 plus 4 multiplied by 3.464 plus 0.232 multiplied by 0.2 divided by 3. So this is what? This is 1.623. Okay. So what will be my error? This is my I numerical. So error will be what? I analytical minus I numerical whole modulus divided by I analytical modulus. Okay. So what is my I analytical value? 1.6405 minus numerical 1.623 divided by modulus of 1.6405. If you find out this value, minus 1.6405 divided by 1.6405. So it will come okay. So this is what we will get. This is the error. Now if you see the earlier error, whatever we have found, this was 0.09 and this is what? 0.01. So this is approximately 9 times smaller than the case for trapezoidal method. Now, if when we have used step size h equal to 0.2 using the trapezoidal method, we have found out the epsilon that was 0.09 in order of that. But for the Simpson 1/3 Simpson case, we have found out the error that is 0.01, which is much smaller than compared to the trapezoidal case. Okay. Clear? Now the remaining part you try to solve, not here, at your home. For the case of suppose trapezoidal method I am using, but I am using the step size as 0.8 and step size as 0.4. Similarly, for the Simpson 1/3 case, if we are using the step size as 0.4, then find out this error. Okay. Now we move towards the next problem, which is like that. So let me add one more page. So this is the problem that we have. So an 8 meter long, 8 long means x dimension, and 6 meter wide metal plate has a temperature distribution T of xy that is defined as 2x plus, 2xy plus 2x minus x square minus 2y square plus 72. This is the temperature distribution. Then we need to calculate the average temperature T average using the step size 4 meter in x direction and 3 meter in y direction, 4 meter in x direction and 3 meter in y direction, using the trapezoidal rule and Simpson 1/3 rule. Okay. Now, if you if you see here, we have discussed, we have revised that the double integration is what? Double integration is what? Summation of series of single okay. This is what the double integration is. So here we have the temperature distribution T x comma y that is defined as 2xy plus 2x minus x square minus 2y square plus 72. I hope this is the formula. Right. So this is my metal plate. Okay. So this has 8 meter long, and we want to take the grid side as in x direction 4 meter. So 8 meter long means two interval we will have. So it will divide it into two parts. Similarly, in y it has 6 meter dimension, but we want to divide as 3 meter. So it will have two such points. So what will the coordinate of this node? 0, 0. What will be the coordinate of this node? 0. No, it will not be 0. X is what here? X is here 4. Y is 0. What is this coordinate? 8, 0. Similarly, here if I write here, y is 3. So 0, 3. Here, what will be the value of this coordinate? 4, 3. What will be this coordinate? 8, 3. What will the value of this coordinate? 0, 6. What will the value here? 4, 6 coordinate. 8, 6. So these are the 9 coordinates that we have. Okay. Now I wish to find out the temperature value at these coordinates. Okay. So suppose if I put x and y, x equal to 0, y equal to 0 in this expression, here I will get 72. Okay. Now if I put y equal to 0, so this term will become 0. This term will become 0. So 2x means 8. 8 plus 72, that will be 80. 80, and this square will be what? 4 square will be what? 16. If I subtract 16, that will be what? 64. Okay. So here I will get 64. Similarly, if I go for t 8, 0, so this will be equal to 0 plus 16 minus 8, 64 minus 0 plus 72. So this will be what? 90. Summation of this and this. What will the value? 96, I guess 72 plus 16 minus 64. That will be what? That will be 24. Okay, this will be what? 24, right? If I am making any calculation mistake, please let me know. Okay. Similarly, e at 0, 3, if I want to find, that will be equal to 0 plus 0 plus 0 minus 918 plus 72. So that will be equal to what? 54. Here we will get 54. So temperature value here is, so this is my temperature values. If I am making any mistake, please let me know. Okay. Now I want to find T 4, 3. Okay. So this will be 24. 4 3s are 12. 24 plus 8 minus 16 minus 918 plus 72. Okay. So this will give me what? 24 plus 8 minus 16 minus 18 plus 72. This will give me 70. Okay. Now T83. T83 we used to find. So this will be 48 plus 16 minus 64 minus 18 plus 72. So 48 plus 16 minus 64 minus 18 plus 72. So this will be 54 again. Okay. You verify this point one more time. Okay. If I put 8 here, so that will become 0. That will become 16. That will 64, 72. So this difference will come as 8. No, it is fine. Okay. Now I need to find out this 0, 6. T 0, 6. Okay. So this will become 0 plus 0 minus 0 minus 36, 72 plus 72. That will be equal to, here T will be equal to what? 0. Now 4, 6. T 4, 6. I need to find. So 24 multiplied by 2, 48. 48. 2 times of x means what? 8 minus 16 minus 72 plus 72. So this will become what? 8. That will become 40. So here T will be what? 40. Okay. Now 8 and 6. If we put T equal to 8 and 6. So 8 if I have put 96 plus if I put 8 here, that will become 16 minus 64 minus 72. This will become 72 plus 72. So this will be what? 96 plus 16 minus 64. That will become 48. Okay. Okay, now I will remove all these. Okay, so this is the value that we have got now. Okay, so now suppose I want to use 1/3 rule. Okay, some Simpson 1/3 rule to find out the Okay, so what will be the T average? T average will be the integration dx dy. X goes from 0 to 8, y goes from 0 to 6, divided by area will be what? 8 multiplied by 6. This is what T average. Now suppose I am defining it as I numerical, okay? I numerical S means what? By using the Simpson method. So I want to find out the I numerical S, okay? This is what I want to find, okay? So, so this is my whole grid. So I can go for, I can first integrate in the direction of X. Then at each X, I can integrate for Y. This is what I can do here, okay? So suppose if I am writing for the case of X, so what will the value? So this will be H of X divided by 3. Here we have the 3 nodes. So first one, suppose I am writing whatever we have get this integration after in the X direction, I have get Y0 plus Y0 means what? Sorry, in the X direction, I am doing the integration. So suppose I am getting, first I am going in this direction. So I have got some X naught. Maybe I should not write X naught. I should write some other term as, suppose capital X naught plus this will be what? 4 times X1 plus X2. Okay. This X1, X2 is what? This X0 is what? Integration of this. This X1 is what? Integration around this. This X2 is what? Integration along this. Okay. Are you getting? So that will be equal to what? Hx by 3. Here I will write hy by 3. That will be equal to what? If I'm writing as this at this in this line. I'm writing in this line. That will be equal to what? T 0, 0 plus 4 times T 0, 3 plus T 0, 6. Okay. This is what we will get. Plus hy by 3. Now at this line we want to write. Okay. So that will be equal to T 4, 0 plus 4 times T 4, 3 plus T 4, 6. Okay. Close plus hy by 3. The last column or the vertical line, I can say that will be equal to T 8, 0 plus 4 times T 8, 3 plus T 8, 6. Okay. This is the formula we have got. Now, if I do some manipulations, so I now I'm using the Simpson method, that will be equal to hx by 3 multiplied by hy by 3, and this will come like that only. So T 0, 0 plus 4 times T 0, 3 plus T 0, 6. Okay. This is the first vertical line plus T 4, 0 plus 4 times T 4, 3 plus T 46, okay, plus T80 plus 4 times. Oh, sorry, here will be 4 times, no? This is 4 times, okay? 4 times T, what? 83 plus T86. Till now it is clear. This is the formula that we have got. Is it clear? Okay. Now we'll put the value here, okay? So this will be equal to what? H of x is what? 4 divided by 3. This is what? 3 divided by 3, okay? T00 is what? Now we'll write the values. T00 is what? 72 plus 4 times T03, 54. And this is what? Plus 0 plus 4 times in the curly bracket T40, 4 comma 0 is what? 64. Then what? 70 plus 4 times 70 plus 40 plus, now here the lowest one, 24 plus 4 times 54 plus 48, I guess. Yeah, 48. Now we want to find out the value of this expression value, okay? So 72 plus 4 multiplied by 54, that will come as 288, okay? Now 64 plus 4 multiplied by 70 plus 40. Okay, so you have got the value, but let me again confirm. Multiplied by 4. Okay. The last one, what will be the value? 24 plus 4 multiplied by 54 plus 48, 288. Now plus 288 plus 1536 multiplied by 4 divided by 3. Okay. So this is the value we have got, 2586. Okay. Now, if I want to find out the P average, that will be equal to I num divided by what? Divided by area. Area is what? 8 multiplied by 6. If I divide it by 48, so this will be y. This will be my P average. Okay. Okay. Clear? Good. Now this expression, and whatever we have found this expression, you try to write for trapezoidal method. Okay. Using the trapezoidal method, you try to write. So here I will write roughly. Suppose I am writing from trapezoidal, so this will be hx by 2. Okay. This will be x capital X 0 plus 2 times capital X1 plus X2. Okay. Now if I put here X1, that X1 will be what? hy by 2 t at 0, 0 plus 2 times t at 0, 3 plus t at 0, 6. Okay. Similarly, this will be what? H1 will be what? Hy by 2, second vertical line, t at 4, 0 plus 2 times t 4, 3 plus t 4, 6. Got it? Like that. You try to write the expression. No? Here only. You try to write the expression. Try to make the grid and write this. Okay, write the expression first. Have you got the expression? So basically in the expression, it will be replaced by 2. Okay. Similarly here it will be replaced by 2. Here it was 4. Suppose. So this 4 will be replaced by 2. This 4 will be replaced by 2. This 4 will be replaced by 2. And this 3 will be replaced by 2. This 3 will be replaced by 2. This 3 will be replaced by 2. Okay. So should we move further? So do we go ahead? So now what we are want to do? Now we want to write a computer program. Maybe that not be possible since there is a time constraint. So we'll write a pseudo code. We'll write a pseudo code. We'll write a pseudo code to calculate the average temperature using a Simpson 1/3 rule by using the n number of divisions. Okay, n number of divisions we will use. The problem is same. We have 8-meter long and 6-meter wide metal plate where the temperature distribution is given. So we want to write a pseudocode for using large number of intervals to calculate the average temperature using the Simpson 1/3 method. Okay. So let me add one more page here. Okay. So same problem, we want to write a pseudocode for that. Okay. So suppose so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 suppose I have here. Similarly here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This is suppose 10 cross 10 division we have. And what will the formula for this in Simpson 1/3 case? Suppose here along this vertical line, it's give me x0, x1, capital X2 like that. This is capital X10, capital X. Okay, capital X10. This is what we have. So if I want to write here, so what will the formula? This average temperature will be what? This sum I numerical divided by 8 multiplied by 6, whatever will be the area. Okay. So I will be what? Hx by 3 x0 plus 4 times x1 plus 2 times x2 plus dot dot dot. Let me write 4 times x3 plus 2 times x4 dot 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 x10. Okay, this is a formula we got. This x capital X is what? Integration along the vertical direction. Okay, so if I write x0, I will be what? Hx by 3. These all terms, this term, all terms will have hy by 3. So simply I take hy by 3 as common. Now I write, suppose here, this coordinate 0, 0, e0, 0 plus e, for this line I am writing now, e, suppose this is suppose ij I am writing. So t 0, 1. This is for the time being assume that if I am writing x0, y0 as 0, 0 and x0, y1 as this 0, 1. Okay. So this will be what? This will be 4 times. Similarly, 2 times t 0, 2 plus 4 times t 0, 3 dot dot dot. Last term will be what? t0, t0. Suppose we have n y terms in y direction. Okay, so this is my first. Now if I want to write this x1, This x1 will be what? 4 times t. Now 0 will be replaced for 1. 1 0 plus 4 times t. 1 1 plus 2 times t. 1 2 plus 4 times t. 1 3 plus t 1 and y. Okay. Similarly, next term I am writing here the third term, that will be plus 2 times t 2 0 plus 4 times t 2 1 plus 2 times t 2 2. Okay, plus 4 times t here 2 3 t 2 comma n y. Okay. Similarly, I write for the last term, that will be equal to 1 times t nx comma 0 plus t plus 4 times t nx comma 1 plus 2 times t nx comma 2 plus 4 times t nx comma 3 plus nx comma n y. Okay, this is what we have. So what is the method we are using here? 1/3 Simpson 1/3 rule we are using. So it has how many intervals? It has even number of intervals. It has even interval, which means what? Odd number of points. Okay, which means it has an odd number of point. Okay, which means since it is starting from 0, which means what? Nx and ny will be even. Here it is clear it till nx and ny will be always even. Suppose here I have written 10 interval, so the last term will be even only because we are starting from 0. Okay. So if you see here, this, now you forget about this term now. This term is common here. So now if you see here, this term is what? This term is multiplied by 1. Okay. Similarly, the last term here is 1. Here is nothing. That this means this is 1. This means this will be also 1. Okay. And this term is also multiplied by 1 only. Means what? This term, and this term, and this term. Okay. So corner will be what? Corner will be, suppose this, whatever it is multiplied by whatever term. Suppose here 2 multiplied by 4, this is 8. So whatever it is multiplied, I am defining as at weight. Okay, weight W. Weight W is what? Multiple. Okay. W. So for corners, W is what? For corners, W is 1. Okay. For corners, W is equal to 1. And for, suppose, now we are going for edges. Okay. Edges. So edges means what? The corners already has been covered. Edges is what? This point, this point, this point, this point, this point, like that. These all points, na? this point, this point, this point, this point. These are on the edges, but not at the corner. Okay. These are the edges, but not at the corners. Okay. So what will the weightage of this? So I am seeing here this x0. X0 means the first one, this one. This one is what? This one is representing this vertical line, this vertical line at the edge. Corners we have already covered. That is has weight 1. If I see here, the edge, this is the edge. So x0, it is x0. Means first term is what? First term is 0. First term is 0. Okay. First term is 0. So now let me write one more thing here. When it will be corner, it will be corner when, if suppose if I am going for I am applying a for loop I equal to 0 to nx, and for y direction I am applying j equal to 0 to ny. So if I equal to 0, 0 means what? This line, or I equal to nx means this line. I equal to 0, or this is a symbol of or, I equal to nx. These two condition, either these two conditions satisfied, means this line or this line, and j equal to 0 or j equal to ny is also satisfied, means what? It is on this line or this line. This is on this line and or this line niche, means this corner point. Then w will be what? W will be 1. Edges means what? Edges means if my I equal to 1, this corners already satisfied, I equal to 1 or I equal to nx, then we will not use and, we will use or. This double pi is or. J equal to, sorry, 0. J equal to 0 and or j equal to ny. Corners are already satisfied. Here I am using not and but or, means what? Either of these two. This point is what? Corner of edge of x, but it is middle of y. So if this is satisfied, then here two conditions are there. If you see here, this is my what? This is one of my edge. So first term is what? Defining the edge. Second term is what? Other point. So if the other point is the other point, these are the other point at the edge, means this is my edge. So this is are the my other point that is defining the edge. So if the other point is odd, so here it is 1. Is it if it is 1, which means what? It will be multiplied by 4. If it is even, then it will be multiplied by 2. So my W can be 4, or here W can be 2. Both can be possible. Okay. When W will be 4, if see if we are at the edge, we already know 0 or ny. If I find out the remainder of 0 divided by 2, that will give me 0. If I found remainder of 0 comma, sorry, nx or ny and 2 nx, this nx is what? This nx is what? Even when I found out remainder, then that will be 0. So means what? If my remainder of I or 2 and remainder of j and 2 both are equal to 0, means what? Both are even. One even will come from edge, one even will come from edge, other even will come from here. Now these points. So if both are even, if you see here, both are even, the weight is 2. So the weight will be what? Here it will be, weight will be 2. Okay. else weight will be 4. Okay, so now we have covered the edges and we have covered the corners also. Okay, edges and corners have been covered. Now we will go for the interior point. Okay, now we will go for interior points. Okay, so what is the interior points? What we will have at interior points? So this is my interior point, no? This is my, suppose this is my line. So this is the interior line, no? So interior line I am now seeing. So this is my interior. So this is what this is at the edge. It will be, we will not consider that. This is my interior point. This is my interior point. This is my interior point. Okay. This is at the edge. It will not be considered. So it is multiplied by, similarly, if you see here, this is also my, interior point. So this is for interior, but this is at the edge. This is interior, this is interior, this is interior, this is at the edge. Now, if you see, this is odd, this is odd, both are odd. Then it is multiplied by what? 4 multiplied by 4, 16. If both are odd, if both are odd, it is multiplied by 4. No? 4 multiplied by 4, 16. One odd, one even, it is multiplied by 2, and here it is 4. So means it is multiplied by 8. Here 4, here 2. Similarly, this is one, both are odd. Here 4, here 4. It is multiplied by 16. Means what? Interior, if I am seeing the interior points, if both I and J are, odd, both are odd. No, this is odd. This is odd. Both are odd. Then W is what? Then W is 16. If both are even, suppose here where it is even, here it is even, no? Both are even. And there will be one more term if I write here, T 2 multiplied by T 2 comma 4. No, if I write one more term. So if both are odd, if I, J, both are even, both are even, then W will be what? 4. If either of those are one odd, one even, then it will be, W will be what? 8. I know this is kind of difficult, but if you write by your own, you will see. Okay. So what for interior points, if I am writing, if I and J both odd, it implies W will be what? 16. If uh, mm, I and J both even, then my W will be what? 4. Else W will be what? 8. Okay. So these are the 1, 2, 3, 1, 2, 3, 6 conditions. Okay. Please respond. Are you able to get? Okay. Now means what? We have found out the W, no? So what we'll do? First we'll define like that. Suppose my L is equal to this. This will be my pseudo code like that. Okay. So L I have defined as 8. Then width I have defined as 6. Okay. Then suppose number of interval nx I want to take as suppose 20 here. Whatever you want to take. Similarly, ny I want to take as 20 or 20, 40, whatever you want to take, multiple of 2. Then what will be my hx? Hx will be what? Hx will be what? L divided by nx. Similarly, hy will be what? B divided by step size b divided by ny. So we have found out the hx and ny. Then we will define some function, temperature function. Now we'll define some temperature function as whatever the function we have, f of x comma y. We'll define this. Then we will define this x and y. How we can define this x and y? We'll define for I equal to 0 to I equal to 0 to nx. Suppose I am defining. So x will be what? X of I will be what? This will be equal to I multiplied by h of x. Okay. Similarly, for j equal to 0 to ny, y will be equal to y of j will be equal to what? J multiplied by h of y. So now I have defined t, I have defined y, I have defined x. So means what? I have created this grid. I have created this grid. Now I just want to know, I just need to apply the Simpson 1/3 to find out this, to find out the whatever it is, integration. Then T average will be what? T average will be whatever the integration I will get divided by the area. That area, suppose I am defining A will be equal to L multiplied by B. For that Simpson 1/3, what I will do, I will start from I equal to 0 to nx. For j equal to 0 to ny. Now I will write down the weight based on whether it is, first I will write for the corner, then I will write for the edges, then I will write for the interior using these conditions. Okay, using these conditions. I will define the W. W will be defined for different condition, we will define the W. Then what we'll do, sum we will define here, sum will be equal to, suppose I have defined 0, then sum will be equal to what? After all if and else statement, I will define sum will be equal to sum plus W, the weight, multiplied by T x comma y. Rather than I should write like that, T of x of I comma y of j. Okay. From here I will find out the sum. After end of the for loop, I will simply do I will be equal to what? Sum multiplied by hx by 3 multiplied by hy by 3. From here I will find, this will be implemented after in for loop. After for loop. Okay. Then I will find out this area I upon loop. Okay, clear? So I will try to give you this code in the whatever link you got here, the Google Drive link. Okay. I hope all these are clear. I tried my best to explain these all. Please respond whether it is clear or not, and so that we can end the meeting.